Okay, welcome to part 5, and we're going to look at Gay-Lussac's law. And this one, he was the one that did the law of combining volumes. And so he also confirmed Boyle and Charles's laws, but also then looked at pressure versus temperature. And he found that at a constant volume, a fixed amount of gas will increase with pressure as the temperature increases. And you've probably felt this if you've ever heated up a can of something you shouldn't do. Don't heat up sealed cans, but they expand. Okay, so again, as we've seen before, pressure is proportional to temperature, and we write that with our nice little constant. P equals a constant times T. Okay, and if we want K on its own, we divide this side by T and divide this side by T, and we get that K is equal to P over T. Okay, so we also know that K can't change if it's the same amount of gas with the same volume. Okay, so therefore we know that our pressure of the first divided by the temperature of our first form of it is going to be equal to if we change its pressure or its temperature, and we can then find out whatever value we don't know. So our example here, these are all the same calculations we've been doing with just different things. So we have a gas in a sealed container at 25 degrees Celsius in an oven. If the initial gas pressure is 100 kilopascals and the final gas pressure is 220 kilopascals, what's the new temperature of the gas? Okay, so firstly, always write down what you have. So we have P1, which is 100 kilopascals. We have T1, 25 degrees Celsius. But we need that. We don't want to use it in that form. We need it to be in Kelvin. So 25 plus 273 is 298 Kelvin. We found this. This is also written on our data sheet looking at the molar volume. Okay, so you can see it there. That's where I told you in the last video. Okay, P2 is also here, there. So it tells us we need to find T2. It says it here. But it's always important to write out what you've got and check your values that it's the right type of units. So here we have our P1 over T1 is P2 over T2. We timed this side by T2. We times T2 over, times that side by T2 times that side by T2. Okay, that cancelled it out. Then we want T2 on its own. This is the way I did it anyway. So we divide this side by P1. So times it by P1, which is divided T1. Okay, and basically with all that sort of thing, if that's something that confuses you, don't stress about it right now. I can help you with this later. All right, so we basically move it around and we end up with T2 is T1 times P2 over P1. Okay, if we do that, on the next page you'll see T2 is T1, I rewrote it there, sorry. And you can see that we then have 298 T1 times 220 P2, just from there, okay, divided by, do that calculation first, then divided by 100. Use parentheses if you have those, but make sure that first one gets done first. Then we equals 365, and because it's temperature, the unit is Kelvin. Don't forget to put units in. But if you need to convert it back to temperature in Celsius, you get your number. You divide it by 270. You subtract 273, and you'll find the temperature is now 383 degrees Celsius. Okay, so that is how we would do that sort of question. And just check what they want the answer to be in if they tell you. All right, so that is a nice short one. That's Gay-Lussac's law. We're going to next look at how we combine them all, but that's the next video.